Ocean acidification, the ocean's inevitable enemy. Hello, Professor. For my final project, I decided to focus on ocean acidification. Before taking this class, I honestly never even heard of ocean acidification, and if I did, I probably would have assumed it was just another form of pollution. After learning more about it, I realized it's actually one of the biggest environmental problems affecting our oceans today. Because, for better or for worse, it changes the chemistry of our seawater itself. Unlike plastic pollution, you can't actually see ocean acidification for the most part, unless you have like a microscope, But its effects can be seen throughout marine ecosystems as a whole. Why should we care? One thing that surprised me while researching this topic is that the ocean itself absorbs about 25 to 30% of the carbon dioxide that humans release into the atmosphere. Sounds like a good thing because it helps slow climate change, but of course, like many things, there's a downside. As the ocean absorbs more carbon dioxide, the chemistry of seawater begins to change. This affects coral reefs, shellfish, fisheries, and even the seafood industry that millions of people depend on. So, while the ocean helps us by absorbing carbon dioxide, it's paying a price as well equally. Well, what is ocean acidification? Basically, when carbon dioxide enters the atmosphere, some of it dissolves into the ocean. Once it mixes with the seawater, it forms carbonic acid. As we know, this chemical reaction lowers the pH of the ocean, making it slightly more acidic over time. Even though the ocean is still considered slightly basic, that small decrease in pH has huge consequences. This is because pH scale is logarithmic. As acidity increases, there's less carbonate available for organisms like corals, oysters, clams, and other shell-building animals to create their own shells and skeletons, as we learned. Here is the NOAA infographic. More or less, this infographic summarizes the entire process pretty well. It starts with carbon dioxide being released from human activities like, driving cars, burning fossil fuels, making electricity, all these things. And then the ocean absorbs some of that carbon dioxide, which leads to, lo and behold, ocean acidification. Along coastal areas, nutrient runoff from farms and cities can make the problem even worse by increasing coastal acidification. The infographic also shows some of the organisms affected and explains that reducing carbon emissions and protecting coastal ecosystems are important ways to solve the problem. For this slide, it's data analysis. As we look on the left, this graph shows how atmospheric carbon dioxide has increased over the past several decades. The line continues to rise as industrial activity and fossil fuel use have increased around the world. As you can see on the y-axis, we have the amount of carbon dioxide, which is in parts per million. And then the bottom is the date, so 1950, 2000, all that. The important thing to remember is that the ocean doesn't absorb all of this carbon dioxide, but it also does absorb a significant amount. As atmospheric carbon dioxide continues to increase, more carbon dioxide enters the ocean, which, all in all, contributes directly to ocean acidification, unfortunately. Now for another data analysis. This is CO2 versus ocean pH. I think this is probably the most important graph in the presentation, if I'm going to be honest, because it honestly connects everything together. The dark line shows atmospheric carbon dioxide increasing over time, as we can see. And then the blue line shows that dissolved carbon dioxide in seawater is also increasing in turn. At the same time, there's a third line, which is the light blue line, that shows the ocean pH, and it's gradually decreasing. Even though pH only changes by a small amount, that represents around 30% increase in acidity, which is huge. And this is because, of course, like I mentioned earlier, the pH scale is logarithmic. This graph clearly demonstrates the relationship between increasing carbon dioxide emissions and changing ocean chemistry. Effects on marine life. In these pictures, we have a nice few things like, clams, oysters, coral reefs, etc. Ocean acidification affects many different marine organisms, but some are impacted more than others, of course. Corals struggle to build their skeletons, making reefs weaker in turn and more vulnerable to damage. Oysters and clams have difficulty forming shells, which is very unfortunate, especially during the early stages of life. Small organisms called pteropods, sometimes also referred to as sea butterflies, I believe we learned that within the module, could even begin to lose parts of their shell in more acidic water. Since many larger fish depend on these organisms for food, the effects spread throughout the entire food web rather than just affecting one singular species, showing, how much ocean acidification really affects our sea. Effects on humans. To be honest, this isn't just an environmental problem. It also affects us in turn. Many coastal communities rely on healthy oceans for commercial fishing, tourism, and recreation. If shellfish populations decline or coral reefs become damaged, businesses and local economies can also be affected. Since billions of people around the world rely on seafood as an important food source, ocean acidification has consequences that extend far beyond, marine ecosystems. So, what causes ocean acidification? This one I'll be focusing on burning fossil fuels. So, the biggest cause of ocean acidification is the burning of fossil fuels, such as coal, oil, and natural gases. These activities release large, and I mean large, amounts of carbon dioxide into the atmosphere, and the ocean just absorbs a portion of it, like we stated earlier in the presentation. Another contributing factor is the overall increase in atmospheric carbon dioxide caused by human activities. The more carbon dioxide present in the atmosphere, the more eventually dissolves into the seawater, which in turn increases ocean acidity over time. Some solutions. Well, although ocean acidification is a very serious issue, there is a few ways we can reduce the impact, luckily for us, although it will be very hard considering all things considered. Let's start with reducing greenhouse gas emissions, which is probably the most effective long-term solution. Ideally, transitioning towards renewable energy, improving energy efficiency, and protecting coastal ecosystems, such as, mangroves, marshes, seagrass beds. This can all help remove, carbon dioxide from the environment. Continued science research and monitoring are also very important so we can better understand how marine ecosystems are changing. Well, what can you do, Professor? Well, most people can't solve ocean acidification by themselves, and I'm definitely included in that metric. Maybe not you. You seem very smart in the matter, but there are still actions we can take. So some simple things like reducing electricity use, driving less when possible, supporting renewable energy, reducing fertilizer runoff, and learning more about the ocean conservation as a whole will all help reduce carbon emissions over time. This is a very debatable topic in my opinion, just because of many reasons. You need to see this on a very, very large scale, which will be very troubling considering how used to everyone is with energy and usage of electricity and all this. So in turn, like I was saying, small individual actions may not solve the problem overnight, but if there's a very, very large effort, a difference could be made. Conclusion. Before taking this class, I never really thought about how the chemistry of the ocean could actually really change. Learning about ocean acidification, and not just ocean acidification, but oceanology as a whole, made me realize that protecting the ocean isn't just about cleaning beaches or reducing plastic pollution, like I originally had thought. It's also about understanding how everyday actions can affect the ecosystem that many will never see, may I add. Hopefully, this presentation showed why ocean acidification is a very, very pressing issue, and why continuing to protect our oceans benefits both marine life and the people. Thank you for listening, Professor, and anybody else watching. Have a great day.